Hello everyone. WoMaster is greeting you on its final webinar from Master in IoT World Series. Today's topic will cover LoRa and LoRaWAN technology for connecting sensors and meters to Internet of Things in industrial networks. I'm glad to introduce today's lecturer, WoMaster's PM Director, Andrew Wang. Andrew, please start your presentation.
Okay. Hello, everyone. My name is Andrew from WoMaster Product Developing Department. And today's topic in the webinar will be the EN110, which is an edge node for the IoT LPWAN network. So let's start the presentation. So here is the agenda today. In the first, I'm going to present you about the LPWAN network review, which I'm going to include the LoRa, the NB-IoT, and the Sigfox. And in the review, I'm going to show you the market review and the network architecture of the LPWAN, and the business model and the technology comparison in the overview part. In the second part, I'm going to show you the private LoRa solution and application in terms of the EN110, which is a LoRa Modbus converter and its related applications. So for the LPWAN, LPWAN stands for the Low Power and Wide Area Network, which is a technology for the long distance, which we are talking about the kilometer grade communication, and the low power communication, which we are talking about the battery powered device. So as you know, the IoT concept has already gained enormous momentum lately. The number of the connected devices is estimated to skyrocket with the next decade. So this momentum is driven strong growth in adoption as the number of connected devices is forecasted to grow at 109% per year until the 2023, reaching more than 1 billion active connection. So while the market fragmentation remains high, the NB-IoT and the LoRa and the Sigfox are emerging as the most popular LPWAN technologies, both in terms of end user adoption as well as whole ecosystem support. So with the NB-IoT and LoRa forecasted to be the dominant technologies over the forecasted period in the public network and private network deployment respectively. So in the later presentation, I'm going to show you mainly about the LoRa and NB-IoT. So the main technology in the LPWAN, the LoRa is operated in the unlicensed band and has some difference frequency in the different region. For example, in the China, the 433 and 4070 will be allowed to use the LoRa. And for the EU, often use the 868 megahertz. And in the United States, the allowed frequency will be 915 megahertz. And on the contrary, for the NB-IoT, is operate on the licensed band, which use the current IoT band. And I'm going to show you some more detail about the band and the NB-IoT later. And for the Sigfox, is also operate in the unlicensed band just like LoRa. And in the EU, is also operate on the 868 megahertz. In the US, 902 megahertz is allowed for the Sigfox band. So the adoption of the LPWAN technology in different market segments relies on how suitable to satisfy the application requirements in terms of, for example, the agriculture, forestry, building and infrastructure, healthcare, industrial, and so on. And nowadays, not one technology will fit all requirements. And oftentimes, application-specific requirement decides which technologies will be used, which means a combination of the LPWAN technology, including Wi-Fi, cellular, Ethernet, are all considered to compose of a complete solution. And in this slide, I'm going to show you the network architecture of the LPWAN technology. As you can see, on the left-hand side, we have some sensor data already deployed in the field side. And one thing you need to do is to add a wireless end node, just like an EN110, to empower the wireless capability to communicate with other devices. So in the top is the LoRaWAN technology. The LoRaWAN requires a LoRa gateway to receive the sensor data from the field side. So you can see that on the right-hand side, the LoRaWAN requests an infrastructure by the user or a system integrator who deploy the network. So the gateway is always required to use a LoRaWAN network. So behind the LoRaWAN gateway, there is a network server if you need to deploy a large scale of network, because more and more things need to be coordinated. For example, the data rates, for example, the join process. So there's some option for the small scale deployment of the LoRa network. We call the private LoRaWAN, public LoRaWAN network, and the private LoRa. So in the private LoRa network, the network server and the related hardware may be not required to deploy in the network. So you can form a small network by using the private LoRa, which I'm going to show you the private LoRa network later. And for the 6FOX is just like the cellular technology. 6FOX will deploy its base station in all over the world. So the infrastructure is deployed by the 6FOX. And most of the case, the 6FOX network provide only the uplink. So you can just imagine that just like your cellular data plan. If you want to use the 6FOX network, you need to pay the data plan for the monthly fee. For example, you need to pay the $1 to be able to send 140 messages per day. This is the current plan I saw on the network. So the NB-IoT is just like the current 4G LTE network as you are using your cell phone now. The infrastructure is also deployed by the carrier. And so here is also a monthly fee. For example, the data plan is provided by the Far East Net in the local Taiwan carrier. It's about $0.3 to provide a 5 megabytes data plan network. So as you can see in the network architecture, the 6FOX and the NB-IoT infrastructure is deployed by the carrier itself or 6FOX. And the LoRaWAN network, you need to deploy your own infrastructure. So there is a difference between the public LoRaWAN and the private LoRa network. And this time I'm going to show you another point to understand the difference of these technologies. It's from the business model. As you can see, for the LoRaWAN, Semtech is the only provider of the IF radio. Then all module manufacturers buy radio from the Semtech, including the NO module and the gateway module. And the data gateway to the cloud depends on the backhaul, Ethernet, or the cellular. The LoRaWAN MAC protocol is open. LoRa aliens believe that the openness creates the adoption. And LoRa aliens want the network operator to deploy the LoRaWAN network, but they also want private company and startup to do the same thing. So the main cost will be the hardware cost to manufacture the end node and the LoRa gateway. And on the contrary, the CIGFAX give away its endpoint technology to whatever manufacturer or vendor want it, as long as the certain business terms are agreed. So the large manufacturer, just like a STM, Atmel, and a TI, can make and manufacture the CIGFAX radio. So you can expect the IF radio will be cheaper than the LoRaWAN. And as mentioned before, CIGFAX deploy its base station, and network operator should pay the royalty to the CIGFAX, and the operator will resell the data plan to the end user, to the end customer. This is for the CIGFAX business model. So here you can see the network owner of the different technology. CIGFAX network. CIGFAX network owned by the CIGFAX, and the NB-IoT network owned by the carrier. So the monthly data plan and fee will be the main cost. And the LoRaWAN network is owned by the user or the system integrator who deployed the end node and the gateway. So the cost here is mainly the hardware cost, including the end node hardware and the gateway hardware. There is no monthly fee between the end node and the gateway. So as a result, the public LoRaWAN that needs a gateway or private LoRaWAN network that utilize only the LoRa radio, no gateway required, can be deployed by application requirements. So I will show you the difference between the public and private LoRa network later. So in this slide, I'm going to present you some more detail about the NB-IoT. The NB-IoT stands for the Narrowband IoT. It is a telco-driven technology, as we mentioned before. It is also international standardized as an increment of the IoT standard in the release 30, which means it can operate in current IoT bands, especially in the sub-gigahertz frequency for the long-distance communication. For example, IoT band 5 for the 850 megahertz and the band 8, just like the current IoT band you are using. The reason NB-IoT can operate in the existing IoT network is because the 200 kHz, the bandwidth, it uses the small bandwidth, so it can be utilized to use the in-band, to use the guard band, to use the standalone mode to implement the NB-IoT. This also implies that the NB-IoT is supported in FDD band only. In such a case, with the upgrade of the base station firmware, NB-IoT can be supported. So therefore, the NB-IoT is natively provide wide coverage support, especially in the urban area. The link budget is up to the 164 dB, which is 20 dB more than the existing IoT network to provide the ultra long distance communication. There are trials in the EU and China, and as you may know, China is the main pioneer of the NB-IoT. Several hundred thousand NB-IoT water meter has been commercialized and deployed in China. Applications such as the light control, parking, or the traffic control are also emerging in China to use the NB-IoT technology. In Taiwan, the local carrier Far EasTone has already completed the whole island coverage of the NB-IoT network this year. So you can see in the right-hand side, the countries and the carrier has already deployed the NB-IoT network for your reference. So from the coverage map here, you can see that the NB-IoT covers mainly in the Asia, EU, and the South America. LTE-M has the higher priority over the NB-IoT in the North America. So you can imagine that the NB-IoT plays an important role in the IoT market with the advantage including the wide coverage or the QoS supported data rates, the low latency, and the infrastructure management. The hardware cost will be a little bit higher because of the NB-IoT uses the OFDM modulation technology. And the synchronized communication to use the NB-IoT is possible to consume more power. So it's a little bit drawback to use the NB-IoT. So you can see that for the battery power end nodes, LoRaWAN will be potentially survive longer than the NB-IoT devices. If we're talking about the 10 years, more than 5 years battery survive time. And the NB-IoT and the LoRa fulfill the different requirements with the different characteristics. NB-IoT can be viewed as another type of the LTE network. You will share the same band, share the same base station in the current LTE base station for your reference. So in this slide, I'm going to show you the different application and then technology applied around when talking about the different application. The first example application will be the smart building. In the smart building, most of the case that you are tracking about the CO2, the temperature, the gas, which is not immediately requirement that need to monitor in the real time. And this data is periodically synced to the server. So you just need to know the current status. And the payload is relatively slow. And the packet loss is also has tolerance. If this time the packet is lost, you can just send again in the next period. So in the smart building application, LoRa will be the suitable technology to use in the smart building. And when talking about the smart meter application, because it requests a frequently access, and the data rate, the data payload in the smart meter will be higher, and the maintainer is required to process it for the emergency state. And the QoS is also required. So you can imagine that the NB-IoT technology will be suitable when in the smart meter application. And for the smart manufacturing, because the requirement is more complex. For example, for some device, you need to frequently monitor for the efficiency. And for some requirement, you need to track the access status to prevent a downtime, to monitor if the device is going to be broken. So in such case, the NB-IoT and the LoRa can be used together to provide the IoT technology. So here is the comparison table of these LPWAN technologies. So from the architecture side, the LoRaWAN is proprietary standard and it operated in the licensed band, unlicensed band. So it could have higher interference. In the architecture side, the gateway is required to form a LoRa network. And compared to the NB-IoT and the SIGFAS, the infrastructure is deployed by the carrier or the SIGFAS itself. So for the hardware cost, the current LoRa module is cost around $10, while compared to the NB-IoT is 12, and the SIGFAS is only $5. And the monthly fee, LoRa network do not need to pay any monthly fee for the network. The NB-IoT and the SIGFAS need to pay the monthly fee. And from the coverage, when we mainly talking about the distance. So there is a typo. The LoRa is around the 10 km and the SIGFAS is around the 40 km. And the NB-IoT is around the 20 km. And the transmission distance and the coverage is depend on the data rate. You need to your application need. I will show you some data rate, how to improve your coverage in terms of data rate or the spreading factor later. And from the application side, the LoRa and the NB-IoT is designed for the bidirectional communication, while the SIGFAS is only for the uplink only. And you can see the maximum payload is different. So in the last column, I'm about the private network. The NB-IoT and the SIGFAS network is owned by the carrier, so it's not possible to form a network. And for the LoRa, it can also operate in the private network, which is the main technology the EN110 used. So what is a private LoRa network? As you can see in the graph below, the LoRa is an RF modulation technology, which we can view it as a 5-layer technology. So for the private LoRa network is used to use the LoRa RF with the private MAC protocol, as you can see here. When comparing to the LoRaWAN, is used LoRa RF and the LoRaWAN MAC protocol. So the private LoRa and the public LoRa is different from the MAC protocol only. The regional frequency is the same. In the EU, in the China, in the US, the RF radio is not changed. So for the private LoRa network, the design is often application specific for the following purpose. For example, to focus on the easy installation, because your customer may need a simplified infrastructure. You don't want a gateway, you don't want a network server over the cloud. And you often design for the easy management. This is discussed about the join process. For the LoRaWAN network, if you have a little bit understand about the LoRaWAN, there are OTA and APPP, two kinds of network, and it also request a network server to adjust between the joining process. And often when using the private LoRa network, it's application specific. For example, you can implement the Ethernet or the DIO or the serial to the LoRa network. So here is the highlights and the appearance of the EN110. As you can see in the left-hand side, the main highlight is this converter used the LoRa long distance communication technology. And the main application will be the transparent replacement of the RS-485 cabling in the Modbus communication. There is no pair requirement because it's designed for the plug and use. If we're using the broadcast, so there's no pair required. And the maximum payload per packet is designed up to the 255 bytes. In the typical sensor data, the data amount is often dozens of bytes. And for the large amount mobile data, is often request in the factory automation. So the 255 byte design can fit all the sensor data or the mobile sensor data. And the power support, including the DC in or the USB 5 voltage power input for the different flexible selection of your power input. And the whole mechanical design is very slim here. So you can check the appearance in the right-hand side. There are two LoRa antenna in the top, and the system LED is on the top view of the box, and it supports the wall mount and DIN rail mount. And in the terminal block connector, 2 pin is for the power and 3 pin for the IS-232 and 2 pin for the 2-wire IS-485. And we also support the micro USB DC 5 voltage for the power input selection. So the traditional deployment of the IS-232 or the IS-485 depends on the factor of the length of the interference, data rate, and so on. So however, the main problem is still the difficulty in the cabling. So by using the Modbus LoRa converter, only a short cable is connected between the master and the slave device. So in such case, the original cable is not required. You just deploy your own master LoRa converter and the slave LoRa converter in the server side and the slave side. So when the sensor side, when the PLC sends the Modbus query, the Modbus converter will broadcast the Modbus request to the sensor side Modbus LoRa converter. So when sensor side receives the request, it will propagate the Modbus request and broadcast the Modbus response to the server side converter. So it's all through the LoRa network to provide the long distance communication. No pair required in such scenario because of the broadcast mechanism. Different operating frequency can be used to divide the LoRa communication into groups to ease the collision environment. So besides, the one-to-one mapping or the one-to-a-chain topology can both be deployed as the original Modbus network. In this slide, I'm going to show you how you adjust the LoRa network regarding the data rate and the distance. The typical question will be, how much data your application required? How much data rate your application required, and how much payload in your Modbus request? And what is your field side environment? So as you can see, the theoretical data rate from 250 bits per second to the 50K bit per second in different configuration in terms of spreading factor and the bandwidth. The rule is that the higher data rate result in the shorter distance. So this factor can be easily set in the configuration utility here. So you can check the user manual for the guide of the configuration. So in our test, The 100-meter distance can be achieved by using the spreading factor 9 and 125 kHz bandwidth when the device is installed in the 1 meter and 60 centimeter height. So here I also give you some example question. So what if the 1,500 meter is required for the communication? The first thing you can do is to use the higher gain antenna if you don't want to change anything. And then the second thing you can do is to install in higher precision. For example, from the 160 centimeter to the 5 meter to provide the ultra long distance capability. And the third thing you can do is to change the spreading factor. The higher spreading factor will be longer, but you need to know when you use the higher spreading factor, the data rate will be lower. So it also depends on your application requirements. So this slide shows a combination of the SCB smart city box and the LoRa technology in the combination. So first, the FCD function as a Modbus RTU to collect sensor data that is directly connected through the RS485 interface. So if the sensor is located in the remote site, and you can deploy a Modbus LoRa converter in your field site cabinet here and here. And to form a LoRa network by install an EN110 also in the SCB box. So in such a scenario, the SCB can function as the Modbus master to broadcast the Modbus Modbus request to the field side, Modbus sensor side, the Modbus LoRa converter. And when the converter receives the Modbus request, it also process the Modbus request and prepare the Modbus response to the Modbus server still by the broadcast mechanism. And then the SCB will pass the sensor data to the SysMax cloud, for example, or the public cloud, for example, the Azure and the AWS. So in the web seminar this year, we are present from the smart city box to the our cloud solution, the SysMaster, and the last time about the vehicle PoE switch, wireless PoE switch, WR329, and to the field side device, the Modbus LoRa converter we present today. And our WoMaster is always viewed as a master in the IIoT world to provide the whole solution, the complete solution to the IIoT applications. So here is the presentation about the LoRa Modbus converter in today's presentation. I'm not sure if you have questions, you can just unmute yourself and ask your question.
Or you can write your questions in chat section.
So anyone has a question or problem about the presentation? Somebody's write message? No? No.
Okay, I wrote where you can write your question, and you see sign chat in case you cannot find it. Okay.
We have some partner to provide a LoRa gateway. So through the LoRaWAN network. So are you asking a LoRaWAN gateway? Yeah, in fact, the SCP has already reserved a place to install third-party device in the SCP itself. Right, there is a WAN port inside the SCP box. So if we put the LoRaWAN gateway inside the SCP can function as a gateway through the WAN port. It should be we already designed for this application. So is there any other questions?
Hi, good morning, good day. Can you hear me okay?
Yes.
Hi, my name's Matthew Smith. I'm from a company called Field Cloud. We're based in Grenoble, Southeast France.
Okay.
And so we're a systems integrator for Internet of Things applications for industry, smart cities, and mainly outdoor applications. Thanks for your presentation. I was just wanting to try and get something clarified. One thing you didn't mention in your presentation was public operated LoRa networks.
Right.
Obviously, with the LoRa technology being invented in France, in fact, the guy who invented the protocol lives in the same town as me. One thing that we have, which is very cool. So yeah, you know, we also have publicly operated LoRa networks, which look and feel very similar to Sigfox and you know, what you mentioned with NB-IoT or any kind of cellular operator. And you know, there are very good use cases which require the use of both public and private, or what we call hybrid LoRa networks. And I was just curious to find out what your thoughts are on that, knowing that there is there are deployments, perhaps not so much outside of Western Europe or certainly France, on public LoRa. So I don't know what you'd like to contribute there.
I know there are some public LoRaWAN network have been deployed worldwide. For example, some vendor just deploy its LoRa gateway and the network server in different countries. Yeah, it's another business model for to use the LoRaWAN network. So I'm not sure if you can have some project info, maybe we can discuss.
Yeah, so we've done a number of different deployments and solutions. So here in France, we work with an operator called Obgenius, who has a nationwide LoRa coverage. Okay. One of the constraints you have in a publicly operated network, if I could just add to my contribution to your presentation, is that due to the duty cycle limitations of the ISM band here in Europe on 868 megahertz, where we cannot exceed 1% of channel occupancy for transmit in the ISM band. So publicly operated networks can support, or are designed to support, a very large number of devices that speak very infrequently. Okay, so publicly operated LoRa networks tend to behave in a similar way to Sigfox's low power wide area network, which is designed to respect this 1% duty cycle. The issue is not on the sensor node, but the issue is on the gateway or the base station. And the base station can only spend so much time transmitting on a particular channel in the band. So this is why LoRa becomes interesting for low power wide area connectivity with a private or with a hybrid deployment of private and public networks. Okay, right. So inside a city, inside a factory, inside some particular outdoor plant where you require sensor nodes to exchange data more frequently. So a good example is where I have a Modbus application, an RTU, that I'm going to connect effectively, having this, as you say, this kind of long serial connection in the sky, that you're going to need to poll fairly frequently, and that will exceed the amount of, let's say, slots that are available in a publicly operated network. So publicly operated networks are great for container tracking, mobility applications, checking if a trash can is full for garbage collection and for route planning, but isn't so good if I have let's say an industrial piece of equipment that is connected as part of process control, where I'm wanting to collect or exchange or even control, send control signals. So the challenge is actually with managing how many downlink messages you need to receive. Okay, so I just, I wasn't sure, when I came into this presentation of yours, how much you were going to cover, and I just thought I'd like to add that to help you out.
Yeah, I guess you are requesting a Modbus converter to use the LoRaWAN network. So for a different model to use the private LoRa or the public LoRaWAN, we can also discuss. I will suggest you to contact our salesperson for the exactly spec and the device you requested.
Well, what's always good is to have a choice of different products, particularly in the solutions that we build. And I think what is great now is I've come to know WoMaster in Taiwan, and that's cool that you guys have got products that can complement. So just to clarify, because the other person asked this question, do you have, so you don't build LoRaWAN gateways, okay? You don't do LoRaWAN gateway, but you do allow those third-party products to be integrated in the packages that you supply. So, great. I mean, the one thing I do like, which has always been a challenge to find at a, in a convenient package, is this kind of outdoor box. So, yeah, some more specs on that would be very good for me, I think.
Yeah, I think we need to more discussion about the complete solution we can provide.
Yeah.
Yeah, thank you.
Okay, we have one more question.
Tom just mentioned about the private network for the factory type. So I personally agree with that. Because the most of case in the private network for the factory automation, customer will request a private network. So in such case, I will think our Modbus LoRa converter will fit to provide the private network in the factory. So that's the different application requirement to use the private network or the public LoRaWAN network. So I think it's still application specific in the requirements.
Hey, actually, if I could just add on to and respond to Tom O'Connor's question there. So it It depends on, I suppose, a number of criteria, but LoRaWAN as a protocol has two levels of encryption and isolation built into the protocol. So we have a network key and we have an application key. So effectively the payload that is sent over the network is doubly encrypted. So it is possible to virtually isolate traffic that transits through a network. So you can actually transit traffic through an operated public network or a private network, and have encrypted data come out and decoded in a private environment. And we find that, depending on the type of outdoor use case, where it is not cost effective to build a private base station and backhaul it, like for example, over an LTE network, over a satellite connection. We find some interesting use cases in remote areas where you are still able to guarantee isolation of traffic. But I would tend to agree that inside a single premise factory, where it's a single piece of real estate on the ground, that you would then be able to, deploy justify the cost of deployment. But a lot of this gets really complicated when you work out the business case and the cost model, the investment model that's required for building infrastructure, and then obviously owning and operating it or having parts of it outsourced. But I'll be glad to speak more if you want to contact me directly on that. It's what we do. It's our core business.
Yeah, I agree with that.
Any more questions? If there are no more questions, we are finishing our presentation. And I want to say thank you to Andrew for your comprehensive presentation, and thank all of our guests for joining and for active participation in our today's discussion. And I have an announcement for the next series of webinar, which we prepared for you to learn more deeply about IIoT technology. These webinars will take place every second Thursday of a month and will last 30 minutes each. So we called it 30 minutes IoT webinar. As you can see, the webinar topics will cover a vast variety of topics on IoT cloud, things integration, edge programming, OTA management, and cybersecurity. We will send you a meeting ID close to the day, so you are most welcome to join us next year for 3 meetings. My second announcement will be about 2019 IoT Master Training, which will be held by our offices in France, UK, Spain, and United Arab Emirates in March. The training will include theoretical part. Here you can see the agenda, as well as practical hands-on part. In addition to acquired knowledge, you'll get 1 IoT gateway and Modbus sensor, a lunch on training day, and IoT Master Certificate. If you are interested, you are welcome to write us to info@womaster.eu. You can also contact us on LinkedIn and Facebook. Just scan these QR codes to open our pages, like, follow, and write to us. So it's the end of our today's webinar. Thank you again for joining. Wishing you the best on the upcoming Christmas and New Year's holiday. We hope to see you on our next webinars and events. Bye-bye.